In section 3.4, we'll be working with sum and difference formulas. And we will use the sum and difference formulas to evaluate trigonometric functions, verify identities, and solve trigonometric equations. So we're essentially doing the same things that we've been doing in the other sections. You just have this new set of formulas to work with. All right, so what we're going to do is we're going to work with using the sum and difference formulas, so the sum of angles, difference of angles for both sine, cosine, and tangent. Let's look what these look like in process. So find the exact value of cosine of pi over 12. Now, what we're trying to do then is we're going to try to find two angles which added together or subtracted will make pi over 12. And really, we're kind of looking for we're looking to use the common angles because we know those trig functions easily without a calculator, and we have fractions to use for those. So when you want to take a look at how can I make pi over 12, it's not going to be adding. So how can we go about making pi over 12? So if I'm going to end up with common denominators. So if we have something like pi over 3 minus pi over 4, and where is this coming from? Well, I only have pi in the numerator here, only one pi, so I'm only putting 1 in the numerators here. I want numbers that are pretty close together that would make a common denominator of 12. So if you take a look at this, this would be 4 pi over 12 minus 3 pi over 12. That's going to equal pi over 12. Though I can use pi over 3 and pi over 4, those are common angles. So now we're going to look at the cosine of pi over 3 minus pi over 4. Because these are common angles, I know their cosine values, and now I can go back and I can use this bit of the identity. So if we take a look at, I use the difference, and if I go ahead and bring this item where I'm working, I can see, okay, this is what I'm going to use. So I want to use the cosine of this angle. So this is going to be angle U, and this will be angle V. Okay, so when we think about pi over 3, pi over 3 has an x coordinate of 1/2 and a y coordinate of radical 3 over 2. And pi over 4 has radical 2 over 2 and radical 2 over 2. And I'm just writing these down so that it's easy to get. This is y and x, and of course then this is sine and this is cosine. So cosine of u would be, right, so we're going to have cosine, let me write it out, pi over 3 times the cosine of pi over 4 plus the sine of pi over 3 times the sine of pi over 4. So we know what these items are. The cosine of pi over 3 is 1/2. The cosine of pi over 4 is radical 2 over 2. The sine of pi over 3 is radical 3 over 2. And the sine of pi over 4 is radical 2 over 2. So when I multiply numerator times numerator and denominator times denominator, this is what I end up, and I get radical 2 plus radical 6 all over 4. Okay, and I could go ahead and make these decimals if I wanted. These aren't multiplied, so I can't really combine them. And I can go ahead and find a solution. So if we want to work with 75, okay, I know that 75 degrees is 30 degrees, that's a common angle, plus 45 degrees, that's a common angle. Right? When you start thinking about 30 degrees and 45 degrees, we have 30 degrees. My x-coordinate is radical 3 over 2, and my y-coordinate is 1/2. And with 45, like in the last problem, it's radical 2 over 2 for each item. All right, so I'm going to add these together. The last time I subtracted, but you'll notice that when we're doing so in this case, I'm going to use a sum formula, and I'm using sine this time. Last time we used difference and cosine. So the sum formula for sine is this one here. And we'll go ahead and bring that over to our problem just to make sure that we follow it correctly. Right, so I know this is going to be the sine of 30 times the cosine of 45 plus the cosine of 30 times the sine of 45. Okay, so you'll notice we've used the sine and the cosine of each different angle. And when we multiply these guys together, sine of 30 is 1/2. Cosine of 45 is radical 2 over 2. Plus cosine of 30 is radical 3 over 2. And sine of 45 is radical 2 over 2. So we're going to get radical 2 over 4 plus radical 6 over 4. And you'll notice we got exactly the same thing. So we're going to get radical 2 plus radical 6 over 4. Right? So we actually got the same things using the cosine difference formula, and it was for different angles. So this is really totally coincidental. It has some roots in complementary angles and the nature of their trig functions, but really that's not part of what we're trying to examine. So the fact that the answers came out the same is relatively moot. Okay, so now we're going to do this again. Cosine of u plus v given, right? So I know that this is going to be, if we go back and we do the sum formula, right? So it's going to be a different one here, sum formula of cosine. So I know it's going to be the cosine of u times the cosine of v minus the sine of u times the sine of v. So let's go ahead and go through what our different items are. So they didn't give me all the information I needed, did they? They gave me that sine of u was 12 over 13. And they gave me the cosine of v is negative 3 over 5. And then they gave me ranges. So I'm going to need to find the other items. But I do have the Pythagorean theorem. I know that sine squared plus cosine squared equals 1. So I know that 12 over 13 squared plus cosine squared will equal 1. So this is going to be 144 over 169. Will be plus cosine squared will be equal to 1. So if I subtract this from either side, cosine squared is equal to 169 over 169 minus 144 over 169. So the difference is 25 over 169. So cosine will be 5/13. Okay, so cosine of u is 5/13, and the sine of u is 12/13. And if I do the same thing with this cosine of v, I know that sine squared will be equal to 1 minus cosine squared, so we won't bother writing out the original again. So 1 minus, and cosine is going to be 9/25. Cosine squared is going to be 9/25. So 25 25ths minus 9 25ths is 16 25ths. So sine will be equal to 4/5. So I know that the sine of v is 4/5, and I know that the cosine of v is negative 3/5. And I really should just double check for validity. This was first quadrant. Okay, so cosine would be positive. This one, on the other hand, is second quadrant. Cosine is negative, but sine is positive. So we're all okay. I just wanted to make sure that I had the correct signs. So here we'll have negative 15, and that's 50, and 15 would be 65ths, minus 48 65ths. So this will be negative 63 65ths. Okay, so I used one trig identity to be able to find the missing trig function. I had sine, I needed cosine. I did use the trig identity, the Pythagorean identity. I had cosine, I needed sine. I used the Pythagorean identity. I double checked what quadrant they were in to make sure that I had my signs correct. And then we were able to go ahead and use in this case, the sum formula for cosine. So in this problem, we're going to work with the sum formula. And you notice this looks a little awkward because now we've got arctan of 1. So we know that we're looking for the angle with a tangent of 1, and we're looking for the angle with a cosine of x, which is complicated. But well, we've gone ahead and I've put together these triangles here that help you to get a sense of that. In this case, tangent is opposite over adjacent, which would be 1. And over here, this is where adjacent over a hypotenuse of 1. So here, cosine equals x. Okay, so just to help you understand where I'm going to get some of these values from. All right, so we're going to be working with this sum formula, so I know I want the sine of arctan 1 times the cosine, times the cosine of v, right, which is arc cosine x, plus, I'm going to go ahead and bring that down here, the cosine of this, so the cosine of arc tan 1 times the sine of arc cosine x. And let's substitute these values. So now the sine from this angle, which arctan 1, so it would be opposite over hypotenuse, so 1 over radical 2, times the cosine of arc cosine x. So, right, the cosine of the angle that has a cosine of x is going to be x, right? So cosine of arc cosine, these things cancel each other out essentially. Plus the cosine of arctan 1, so the cosine would be adjacent over hypotenuse, so that's also 1 over radical 2, times the sine of arc cosine x. So the sine would be this side, which we found from the Pythagorean theorem is the square root of 1 minus x squared over 1, right, opposite over hypotenuse. So that's just going to be 1 minus, the square root of 1 minus x squared. All right, when we go ahead and multiply these out, I'll get x over radical 2 plus the square root of 1 minus x squared over radical 2. And this is, when we simplify it, we already have common denominators. It's x plus the square root of 1 minus x squared all over radical 2. And we could rationalize the denominator. This would be radical 2 times x plus the square root of 1 minus x squared all over 2. So this is an algebraic expression. So we converted a trigonometric expression to be an algebraic expression. Okay, no trig functions. Okay, mostly takes being careful, taking your time, carefully substituting and simplifying. All right, so now we'd like to use the difference formula. Again, this is the sine difference formula, so let's get that. There's the sine difference formula. And we're going to put that over here so we make sure we follow it correctly. So I know I'm going to have the sine of x times the cosine of pi over 2 minus the cosine of x times the sine of pi over 2. And I want to prove that equals the opposite of the cosine of x. So the cosine of pi over 2. So go back to the unit circle. Right? In the unit circle, pi over 2 is right here. And this is 0, 1. Okay, so 1 would be here. So we'll have sine of x times 1 minus, I'm sorry, my mistake. This was times the cosine of pi over 2. Cosine is 0. My mistake, 0. Minus the cosine of x times the sine of pi over 2, which is 1. Sine of x times 0 is 0. Minus 1 times cosine of x is cosine of x. And 0 minus the cosine of x is the opposite of the cosine of x, equals the opposite of cosine of x. And there we have used this to prove the identity. Okay, so sum and difference formulas can be used to rewrite expressions like these, where n is an integer, right? We have an angle plus another angle. As expressions involving only sine of theta or cosine of theta, the resulting formulas are called reduction formulas. So if we want to go ahead and derive these, we want the difference sine and the difference tangent. Let's go ahead and get those really quick. Here's the difference tangent. And I'm going to grab that one. And we used the difference of sine on the previous page, so I'll just copy that and bring it over. All right, so I know I'm going to have the sine of 3 pi over 2 times the cosine of theta minus the cosine of 3 pi over 2 times the sine of theta. Let me move this guy over. It may have been ambitious to try to do 2 of these on a single slide. 3 pi over 2. So let's think about where 3 pi over 2 is. So here's pi over 2, 2 pi over 2, 3 pi over 2. So x is 0, y is negative 1. So sine here would be negative 1 times cosine of theta minus cosine of 3 pi over 2 is 0. So this is just going to be minus 0. Right? Sine of theta doesn't really matter. So this becomes the opposite of the cosine of theta. Okay, and if we look at tangent, this is a little more complicated because we now have a fraction. So I'm going to have the tangent of theta minus the tangent of pi over 4 divided by 1 plus the tangent of theta times the tangent of pi over 4. So pi over 4. Pi over 4 is right here. Right? This one over here was 3 pi over 2. Here's pi over 4. Pi over 4 has an x and a y that are square root of 2 over 2. They both are. So then tangent of pi over 4 is going to be equal to 1. So I have tangent of theta minus 1 over 1 plus tangent of theta times 1 plus tangent of theta. Okay, so when we simplify this out, this is where we end up. So if I want to work with this problem, we're going to solve the trig function in this interval from 0 to 2 pi, so once around the circle. And we're looking at, we've got a sum sign formula and we've got a difference sign formula. So I've got these written down here. So I know I'm going to have the sine of x times the cosine of pi over 2 plus the cosine of x times the sine of pi over 2 plus, now I'm going to do the difference over here, sine of x times cosine of 3 pi over 2 minus cosine of x times the sine of 3 pi over 2. Sorry, my handwriting is pretty bad here. So remembering from our unit circle again, pi over 2 is up here, 3 pi over 2 is down here. So up here we have 0, 1, and down here we have 0, negative 1. So in both cases, cosine is 0. So this cosine, so I'm going to have sine of x times 0 plus cosine of x times the sine of pi over 2, which is 1, plus the sine of x times the cosine of 3 pi over 2, which is 0, minus cosine of x times the sine of 3 pi over 2, which is negative 1. So that's 0 and that's 0, so I end up with the cosine of x times 1, which is just cosine of x, minus the opposite of cosine of x, and it's going to equal 1. Sorry, I had left off the equation before. So this becomes 2 cosine x equals 1. If I divide by 2, cosine of x equals 1/2. So where in the unit circle, right, from 0 to 2 pi, that's what's around the unit circle, does my x coordinate become 1/2? Well, that's here and here. Okay, so this is pi over 3. And this is negative pi over 3, essentially. So if I have 2 pi, which is 6 pi over 3, minus pi over 3 is 5 pi over 3. So those are my solutions in that interval. Okay, and our last example from this chapter is wanting to verify the identity. Remember again that we're working with, we're going to change one side of the equation. So over here I have a sum formula for cosine, so that's probably what I'm going to be working with. Let's go ahead and grab that. All right, so I'm going to go ahead and change this side here in this manner. So I know that I'm going to have cosine of x times the cosine of h minus the sine of x times the sine of h minus cosine of x all over h, and we want that to equal cosine x times the cosine of h minus 1 all over h minus this other fellow, so we're going to get there in a second, minus sine of x sine of h over h. All right, okay. So what I'm going to do in the numerator is I'm just going to reorder these a little bit and create some groups. So I have the cosine of x times the cosine of h minus the cosine of x, and I put these together minus the sine of x times the sine of h. And I put these together because what I'm going to do next is I'm going to factor this. So as we go ahead and pull this out, I factor a cosine of x out of here. I'll have cosine of x times cosine of h minus 1 all over h, and I can distribute this division, sine of x times sine of h over h. And if I want to make this look, this is in the numerator, so I could say this is cosine of x over 1 times cosine of h minus 1 over h. That means I've done this part. Minus, right, that's a times. If I pull the sine of x out, sine of x over 1 times sine of h over h. And that is this part. Okay, so now I have made this side match that side. A little complicated. It was important to realize that if I move this over and factor it out, I could get to where I wanted to go. I used, of course, the right side of the equation as a guide for what I wanted to do to the left side of the equation, and we used the sum formula to get us started. That's it for this section. What we did is we worked through the sum and difference formulas for sine, cosine, and tangent. We used examples to evaluate trig functions, we verified identities, and we solved trigonometric equations.